Lesson 3.3, Rate of Change and Slope. Our essential question today is how do you find the rate of change from a graph or table? We've already learned about the slope of a line. The rate of change is another term for slope. The rate of change also means how much something changes over a set interval. Along with slope, remember we said that it was rise over run. The rise is how much y changes, and the run is how much x changes. That triangle means change. So we're going to be looking at graphs and we're going to be looking at tables, and we are going to find the rate of change and then interpret what that means about a situation. Okay, our first table says use the table to find the rate of change and explain its meaning. So in my table, I'm going to clone my table. So that I can write on it for you. Maybe. There we go. Okay. So I am going to find the rate of change, or the change in y divided by the change in x for each of these intervals. So y, how much is y changing? 118 minus 59 will tell me how much y is changing. So 59. And then over here, how much x is changing? 1. So my first rate of change, 59 divided by 1, or 59. Then my second rate of change, I need to check. $59 again, and 1. So 59 divided by 1, 59. So what this is telling me, my rate of change is a constant. It was 59 each time. That 59 represented the total cost, and it was for a number of video games. So what this is telling me is that the video games cost $59 each. So as I was buying one more video game, the total cost was going up $59 each time. So video games are $59 each. That's the meaning. Okay, my next situation, I'm going to do the same thing. Okay, so for this one, we're talking about the number of floor tiles and the area of the tiled surface. So this is if you're tiling at your house, like floor tiles, might be ceramic tiles, you're tiling the kitchen or bathroom entry. So the number of floor tiles, 369, and then the area of the tiled surface. So I need the change in y divided by the change in x again for my rate of change. So First one, 96 minus 48 is 48. 6 minus 3 is 3. Second one, I have to make sure it's the same. So 144 minus 96, 48 again, 6, 9 minus 6, 3. Okay, so on this one, my rate of change, I have to divide the change in y by the change in x. So rate of change, my change in y was 48. My change in x was 3. 48 divided by 3 is 16. 16. So I look at my labels and I see that that was inches squared. So 16 inches square, and we're talking about floor tiles. So I'm going to say each floor tile covers 16 square inches. That's the meaning for my rate of change. Okay, now we're switching over to a graph. Use the graph to find the rate of change from 1995 to 2000 and 2000 to 2005. Is it a constant? Is it a constant? So, the rate of change in y, divided by the change in x. Okay, for our first interval right here, the change in y. This is my y-axis over here. We're talking about the number of departures from U.S. airline departures in the millions. So y changed, it was in 1995, it was 8.1, and in 2000 it was 9.0. So the change in y, I'm going to show you what it means on the graph. From this point to this point, in green, this is how much y changed. So 8.1 and 9.0. So I'm going to subtract 9.0 minus 8.1. Notice I started at 2000. And then my x change is right here. And my x change down here would be the years 2000 and 1995. It doesn't matter which direction you decide to subtract. If you want to start with the smaller one, it's okay. It's just that you'll end up with negative numbers. So if you prefer to subtract this way, go ahead. Just make sure that you are starting with both of the coordinates for this point on the left, okay? So either way you can solve this. So if I subtract 9.0 minus 8.1, I get 0.9, and then subtracting the years, I get 5. So 0.9 divided by 5 is 0.18. And the same thing would happen. I'd just get negative and a negative, so it would still give me 0.18. Okay, so you can subtract it either way that you want. So I found the first interval. So I'm just going to stick with my original. And then now I'm going to work on the second interval to see if it's a constant, because our questions were to find each rate of change, and then they're asking if it was a constant. So now I'm looking at this change in y, and then this change in x. Okay, so y went from 9.0 to 9.9. So subtracting those is 0.9 again. And then the change in x this time, 2005 to 2000. So still a 5-year interval. So if I divide that, I will get the same thing. So is it a constant? Yes, it's a constant. And it is a constant 0.18, and I would have to say this is million departures per year, because that is what we were talking about in this table. So make sure that you are able to understand the meaning of the rate of change, whether it's coming from a table or a graph. Okay, our next one, same idea as the last time. Now we're talking about US passports that were issued, still millions, still years. So my first interval, this is my change in Y and my change in X. So change in Y would be 8.9 minus 7.0, and the change in X would be from the years, so 2004, 2002. So subtracting these gives me 1.9 in two years. So 1.9 divided by 2 is 0.95. My second interval, oops, that wasn't very good. Here's my first one. So my second one's got to come up higher like this. So change in Y, change in X. Okay, so my second interval in red, I have 12.1 and 8.9, and it's from 2004 to 2006. So it's still a 2-year interval. 12.1 minus 8.9 is 3.2. So if I divide that, I get 1.6. So is it a constant? No. The number of passports per year is not a constant. It changed from 0.95 million to 1.6 million. Okay, our last type of problems for this section. Determine if each function is linear and explain. And then the hint says, is the rate of change a constant? Constant rate of change means that it is linear. Constant rate of change. Okay, because if the rate of change is constant and you graph it, that slope is staying the same, that makes it linear. It makes it linear. So if I find this rate of change, so change in Y divided by change in X, now remember I have to do each interval. So 12 minus 6 is 6, 2 minus 1 is 1, so 6 divided by 1 is 6. That's my first interval. I'm going to switch colors for you. Next one, 18 minus 12 is 6. 3 minus 2 is 1. 6 divided by 1 is 6. You have to check every single interval, because if one of them, oops, I wrote that one the wrong way, if one of them is different, it's not linear. Okay, so this one, the rate of change is 6 every time. So determine if it's linear. Yes, it has a constant rate of change of 6. we don't know what that 6 represents because this table simply says X and Y, so we don't have to worry about putting more meaning onto this one. All right, one more. Notice when I'm subtracting on the ones up above, I always started with the one on the bottom, so I'm still going to do the same thing here. So 1 minus 5 is negative 4. And this gets a little bit tricky. And then x, negative 2 minus negative 10. This turns into a chunky plus, so that would be 8. So this rate of change is negative 4/8 or negative 1/2. My next one, negative 4 minus 1 is negative 5. And then 6 minus negative 2. So I'm subtracting the coordinates to find the rate of change. This would be a chunky plus, so it's 8. So negative 5/8 does not reduce to negative 1/2. So I don't even have to solve the last one because I can already tell that the rate of change is different. So no, this is not linear. Because the rate of change is not a constant. All right. You should be able to write a summary now and work on your homework problem.